The original idea, I think, was born in South Africa.
With our new hybrid system, we aim at developing compact and efficient cooling systems that are resistant to wind effects, hot recirculation effects, as well as high ambient temperatures.
This product is kind of the first in the world of its scale. So there are similar deluge systems, but integrated deluge system does not exist.
We are investigating several technologies within this project.
And this main focus here is to improve the heat exchanger technology. Therefore, we decided to have a closer look on this dry-wet cooling or hybrid cooling system.
Then there's a second technology where we develop axial flow fans to improve the fan static efficiency.
There are certain effects that are scale dependent. So we usually try and accommodate that when we do laboratory scale testing.
Let's talk a bit about the full-scale test facility itself. So this facility allows us to conduct tests on two fronts, so it has a dual purpose. The first part is that we have a fan test section. The fan test section is specifically made for a 24-foot axial flow fan.
Within the project, we were tasked to develop a 24-foot, what we term a CSP axial flow fan.
We don't engage in catalog engineering. We design a custom fan for a specific duty point. We've now manufactured the 24-foot CSP fan for this facility.
We also have a deluge test section, or a deluge heat exchanger test section that is downstream of the fan test section.
Specifically for the deluge system, there does not exist a full-scale system. And water retention on such a large scale needs to be tested to that scale. What we need to take into account is that industry by nature is conservative, because they work with other people's money. Often it's investors, and those people want to know that their money is well spent. And what you have with a facility like this, you're able to bridge this gap between lab scale, where you almost at academic level, you have these fabulous ideas and the wonderful things that you see into the future, and industry, where you want to have, for instance, a power station that runs and works and is reliable. And this facility is able to bridge that gap, literally to a point where you can have people from industry visiting and show them the full-scale application of the system in order for them to assess it better.
Ultimately, what we try to achieve is that we want to have a system that you can control, that gives you sufficient power output during adverse atmospheric conditions.
And therefore we looked for a different solution, and this is this dry-wet cooling deluge system, and not having a serious or larger impact on the footprint and also on the investment cost. That was our idea and also the challenge of this project.